Hi all, welcome to the first episode of a new series, the UNS and Ignition. As you might have seen, the film setup has been upgraded a bit compared to my last videos. Shout out to my neighbor Andreas and the editor Joppe for helping me on this. If you have been exploring the unified namespace, you've probably heard of the Ignition platform as well. And you might have wondered, how do I actually implement this in a real-world Ignition project? Well, you're in luck, that's exactly what this series is for. And I'll be walking you through how you can integrate Ignition into the UNS and giving you practical hands-on examples so you can build your own setup. If you are new to the UNS and need a solid introduction, I highly recommend checking out the video from 4 of those solutions in the comments. Before we dive in, let's talk about why implementing the unified namespace is a good idea. The first reason is all system integrations become event-based. I don't know if you've ever heard of the term big ball of mud, but it is present at most manufacturing companies. It looks a bit like this. It means that everything has a connection to everything, to the point where no one dares to touch anything because it might break. Event-based integration means moving over to a structure that looks more like this. A second reason is scalability. It allows you to compare production lines even when they have different vendors and their PLC structure looks totally different. This enables a much easier scaling of your proof of concept across lines and across sites. The third reason is, in my opinion, the most important one, and it is communication. The UNS improves cross-team communication. Everybody speaks the same data language. I personally believe this is one of the key drivers of innovation for any company. It makes data useful for everyone, from your operators to executives, not just your automation engineers. And when people ask me what my company, Mastery Solution, does, I always say we help companies gain insightful data from operator to CEO. And that is only possible if the data actually makes sense for both of those sides. But how do we get there? How do we get to a good unified namespace, and in this case with Ignition? Well, it all starts with setting up Ignition and start with collecting data. So I'll be going through 3 main Ignition architectures, and as a disclaimer, there are many more Ignition architectures. I specifically focus here on architectures for manufacturing plants with the purpose of building a unified namespace. So again, there are much more options with the Ignition as a product. When starting a new project, we first decide how to structure Ignition at each plant. There are 3 main approaches. The first one is edge-based modeling with Sparkplug B. The second one is edge-based modeling with remote tag providers. And the third one is a single Ignition server. But why would we talk about the architecture first and not just jump straight into building the UNS itself? Well, it's because a solid foundation is the key to future success. Let's break down each option. The first option, edge-based modeling with Sparkplug B. How it works. In this architecture, data is modeled and processed at the edge, meaning close to the actual production equipment. This data is then transmitted through Sparkplug B and could also be transmitted through flat MQTT to an MQTT broker, and then going into Ignition via the module MQTT engine. Essentially, the edge devices pre-processes and standardize the data before sending it upstream. What are the advantages of this architecture? First one is load distribution. Instead of burdening one central Ignition to handle every data point and every connection with a PLC, the edge device processes the data locally before sending it. This reduces the strain on your backend system and ensuring more efficient performance and scalability for your main Ignition server. The second advantage is improved network security. Because you have your edge devices so close to the edge, you can have small VLANs at every production line, and you can close that network completely off, having outbound connections only. A third advantage is, since data is structured at the edge and it follows the Sparkplug B standard, you're not locked into any vendor. Like you don't have to pick ignition here. You can replace your main ignition, or you can replace your edge devices, but you still have alternative solutions while you're maintaining the same data modeling. So this flexibility, this allows for future expansion, and it really is a good thing for people who like to be vendor agnostic. The fourth advantage of this system is auto detection of new devices. Higher level systems can automatically detect and integrate newly connected devices that come in through Sparkplug B, and this reduces the manual configuration and speeds up the deployment of additional machines or sensors. Some challenges with this architecture is the UDT maintenance, keeping your definitions in sync. When multiple edge devices manage their own data models, maintaining a uniform UDTs across all locations can become challenging. It's simply not easy to maintain Sparkplug B UDTs in Ignition. You could tackle some of this burden by putting in very good scripts that can help you managing it, but in most cases we simply will not push UDTs through Sparkplug B because it is such a pain to manage. A second challenge that you might have with this architecture is the fact that you have a lot of edge-based modeling that you need to do, and you have a lot of edge-based devices, and it can be a burden to just manage all those devices and manage all those versions, those EDTs. That's a disadvantage, but it can be solved partly with using Ignition Enterprise Administration module. But in that case, you're going back into being locked in with a very specific vendor. So then it becomes less open, but it becomes easier to manage. You could also do a full Git integration where you just have a full Git flow to deploy everything to your edge devices, or to keep your devices in sync with each other. You could use Git for that. That's maybe a little bit less vendor specific. Another challenge you might have with this approach, with this architecture, is when you're using Ignition Edge Panel, you might want to have a lot of history in there, but by default the history will only store for 35 days unless you actually connect through the Ignition Gateway network. So if you really want to be vendor agnostic, you might come into some limitations where you cannot use the full power of the Ignition ecosystem, of course. The second architecture is edge-based modeling with remote tag provider. How it works. Instead of sending data through Sparkplug B, this architecture connects edge devices directly to the central Ignition Gateway using the remote tag providers. Each edge device acts as an independent data source, but the main Ignition Gateway maintains full control over all tag configuration. What's the advantage of using this architecture? Well, it maintains your benefits of decoupling. Like in the first example, you still have the same benefits where when you decouple, you have your load at the edge, and you can do your modeling completely at the edge. So that's a bit of the same as the previous one, but this one does it within the Ignition ecosystem, not using MQTT. The second advantage is, because the tag definitions are managed at the central Ignition Gateway, you can do your updates and your modifications without you needing to log into each edge device. This reduces a lot of the headache to maintain all of the devices and makes it a lot easier because you can do everything from one user interface in your system. What are challenges with this specific architecture? Well, the first one is obvious. You get more locked into the ignition ecosystem. You go from ignition to ignition using ignition technology. So it's harder to put something else in place in there. But again, you could solve this if bandwidth is no issue. You could use the complete ignition ecosystem, but you could still publish your data through MQTT and still have your data in a decoupled way moving up the stack. That brings us to the third architecture, and that's just modeling in ignition, one ignition gateway. All data is handled directly within a single ignition server. So you would have all your device connections, all your tag definitions, all the data processing. And this is by far the simplest setup. You only have one server, everything is managed there, all the logic is there without the need for edge processing. That's also the main advantage of this setup is the fact that it's very straightforward and it's very easy to maintain. And the second advantage is it's not only easy to set up, it's also easy to expand. So let's say you hit your performance limit on your server and then you need to expand. So it's very easy in Ignition to just set up a backend server that might be doing all the PLC connection and then having your front end more user face. It's very easy to make your system bigger, but then of course you come a bit into the previous architecture. What is the challenge of using a single ignition? Well, the first one is a single point of failure. Just because you don't have your edge devices, you also don't have logic that is happening at the edge, so you won't have a backup strategy there. Unless, of course, you use Ignition's redundancy strategy, which actually solves a lot of that and always make sure you have a backup. The second challenge is because you don't have edge processing, you might hit your limitations sooner. So what approach should you pick? Well, unfortunately, there is no one-size-fits-all answer. It really depends on your vision and where you want to go to. So it also depends a lot on the size of your project. It depends on the number of tags that you have. It depends on your long-term architecture philosophy and where you want to go to as a company. The right choice will depend on your specific needs. But I hope with this video, it's at least a little bit more of an informed decision when you're making one. If you'd like a full step-by-step example of setting up a unified namespace-ready architecture, drop it in the comments below, and I'd love to hear what you think and what specific challenges that you are facing. Thanks for watching, and I'll see you in the next one.